Hello class, welcome to chapter 3, and we begin with 3.1, which is to define the derivative. 3.1 is a rather long section, so I am going to give it to you in parts. So the first part is 3.1.1, that's how I'm kind of organizing it. So you know that that's the first part in 3.1. This is to do with secant lines and average rates of change. We did see an introduction of this when I gave you a preview of differential and integral calculus in 2.1. Here we're going to go a little deeper into understanding secant lines and average rates of change so that we could use it to build our definition of the derivative. So we have three objectives, as you can see here. Let's start with the first one, which is the average rate of change of a function between 2 points on a curve. So this is a definition you're familiar with, right? The average rate of change between 2 points. So when we define this, we like to keep the 2 points not as x1, y1, x2, y2 as we did in algebra, but we will try to understand this as a point A, comma f of A, and another point which is h units away from A. So you can see that it's A plus h here, right? So h units away from A. So it could be to the left of A, to the right of A, because you can keep your h positive or negative to see how far away it is from A. If A plus h is the new point, its corresponding coordinate for the function would be f of A plus h. And so we're saying, well, this is the same as you had, I can write it out here. This is the same as your slope formula, which was y2 minus y1 over x2 minus x1. Now, instead of y2, you now have f of A plus h, because that's coming from the second point. The y coordinate, you take the difference of the y coordinates over the difference of the x coordinates. So it's A plus h minus A. The a's cancel off, leaving you with the h. And you have seen this as difference quotient in pre-calculus. So you're familiar with this. We're just trying to write the formula using A plus H and A instead of, X2 and X1 or, F of, or Y2 and Y1 and so on, right? So we can tweak this as we, as it depends on the problem. So let's take a look at the first one. Find the average rate of change on the function f of x from x equals 1 to x equals 3. So you can notice that you are not given coordinates, you're given x points, because that makes sense. From 1 to 3, what was the change in the rate? What was the average change in the rate? So, we write average rate of change as ROC, average rate of change. It's a quick way for you to recall that. In order to find that, we have x1, right? Or we could call this x1 or x as A, because we're using A and A plus h. I would like to use those letters so it's easy for us to make a comparison. A plus h is 3, right? So f of A, I write that here. F of A is basically your f of 1. So evaluate what happens when you plug in 1 in your function. So 2 times 1 squared plus 1, which is equal to 3. And then f of A plus h, which is your second point, is f of 3. Again, plug the 3 in your function, and we get 9, 18, 19. So from A to A plus h, right? From 1 to 3, you had to move a distance of 2, right? So your h is nothing but A plus h minus the A. Let me write that as well. A plus h itself was 3, and A is 1. So your difference is 2. So we have all these details. Go ahead and enter it in your formula. And the way we plug them in is the way you had it in the formula. All over h. And since we figured these out earlier, you just have to plug them in, which is 16 over 2 equals 8. So the average rate of change is 8. Another example, let's try using the trig functions here. Find the average rate of change on the function f of x equals sine x from x equals 0 to x equals pi over 2. You can at this point pause the video and try it yourself if you'd like. So the first point we're calling a, and the second point is a plus h, which is pi over 2. Okay. So f of a is f of 0, which is sine 0. Sine 0 from your unit circle is 0. Remember the unit circle, so you need to go back and reference that. F of a plus h is f of pi over 2. So in your sine x, replace x with pi over 2. Again, if you look at the unit circle, pi over 2 is your 90-degree mark, and that gives us a 1. Okay. Your h is a plus h minus a, which is pi over 2 minus 0, which is pi over 2. Now I can use the formula for average rate of change, which is basically the slope of the secant line. F of a plus h minus f of a over h, which is 1 minus 0 over pi over 2. Clean this up and you get 2 over pi. And this is your average rate of change. Let's go to the next one. This is a different representation. Here we're asking you to find the average rate of change between x equals -3 and x equals -1 for the table shown below. So we didn't give you an explicit function. Instead, it's given to you in a tabular form. Does the formula change? Of course not. It doesn't change. We just have to remember that we are now looking at it from the table. So a is -3, right? And a plus h is -1. So f of a is f of -3, and see what it gives us. So go to your function where f of x, you go to the x column and then you look at the corresponding f of x for x equals -3, and that gives us 23. Likewise, f of a plus h is f of -1. Go to the x value, which is -1, and find its corresponding f of x. Because you also have -1s in the f of x, so don't get confused. I'm sorry, not f. The value itself is 7, the 7. Yeah. And of course, a plus the h, the difference in h can be found as well. But just for variety, I'm going to put that right in the formula as we see it. So f of a plus h minus f of a over a plus h minus a, right? Because a's will cancel off, we know that. But I'm just going to trying to show you that you could do the h value in the formula itself. You could plug it in and work on it right there. So this is, where are we? This minus f of a is 23, okay, 7 minus 23, divided by a plus h is -1. So -1 minus a is -3, right? So that gives us the numerator comes out to be 19, -19. Oh, sorry. What am I doing? So we have negative 16 over, that will be a plus, so 2, and the answer is negative 8. And are these two become positive? Negative 1 plus 3 is positive 2. All right, let's look at the next one. What if this came as a graph? Can we still do this or respond to the question, average rate of change? Well, absolutely, because you know that an equation, a table, a graph are all different representations of the same information. Okay, so we have to use the graph to find our corresponding functions f. So I just want to mark negative 1 for the x, right? So this is negative 1. See where it hits the y-axis. So when x is negative 1, it implies f of negative 1, right, is pointing to the value 3. And the other one was x equals 1. When x equals 1, you see where it hits the graph? It hits the graph below, and it points to negative 1. So when x equals 1, it implies f of 1 is negative 1. And if you look at the distance from one point to the other, your h is 2, isn't it? Because you're negative 1, you move two squares away to get to 1. So we got that. So you can even say h is 2. And then you can find the formula. Use the formula to find the average rate of change, which is f of 1 minus f of negative 1 over h. F of 1 was negative 1 minus f of negative 1 is 3 over h, which is 2. So we get negative 4 over 2, which is negative 2. And that's how you use the graph to find the average rate of change. Now this is interesting because this is how it'll look more and more in calculus, where you are not given two specific points, you're given 1 comma t. Again, the rule is still the same, so let's not get confused with that. And what they gave us was an interval, right? An interval 1 to t would mean that you start at x or a and go to a plus h. This is an interval on the x-axis. So it is not a coordinate. If it was a coordinate, they would have mentioned that. They wouldn't call it interval. So don't go by the way it's presented, because sometimes you can even have open intervals. So you shouldn't get confused with the coordinates. If they said coordinates, they will say x1, x2, or they'll give you more details. They wouldn't use the word interval. All right, interval here indicates that a is 1 and a plus h is t. So f of a is f of 1, which means I can plug in 1 in the place of x. That gives us negative 1. And here, f of a plus h is f of t. So wherever x occurs, you're going to plug in t. So it's as if your formula remained the same. Instead of x, you now have a t, which is true. That is what we have. So this is going to give us a result that is not numerical. It'll be still an expression. And we can see that this expression can be utilized when we know a specific t value, right? So that is the benefit of having it in t. So we can use it for any distance from a, which is 1, right? T could be any distance from a. All right. Your h is the difference in the intervals, t minus 1. Okay, AROC is f of a plus h minus f of a all over h, which would be 2t squared plus t minus 4 minus a negative 1, because it's minus f of a. F of a itself is negative 1, so remember that, over t minus 1. So you are actually getting an algebraic expression. Let's get more space here. So 2t squared plus t minus 4 plus 1. In fact, you can kind of combine it and make it as minus 3 over t minus 1. Although you could leave the answer like this, you always have to make sure that you factorize it if it's possible. So if it is not factorable, then it makes sense to leave the answer as it is. Okay. So for this, you have to use your knowledge on factorization of polynomials, especially quadratics. So you remember the X method, the AC method, the diamond method. You have the quadratic formulas. You have all these types that you could use. So the book talks about AC method, which is factoring by grouping. So your A is 2 from your quadratic. It's ax squared plus bx plus c, right? So that's where you get the a, b, and the c. C is negative 3. So AC method or factoring method says, look for, multiply the a and the c, you get negative 6. B is 1. Look for two numbers whose product is negative 6 and whose sum is 1. And then you'll replace the middle term with that. So 2t squared. And this t, you have to find something that will work for this t, right? Replace with those two numbers. So you can think of various factors that will do this trick. You want those factors to add up to 1, but multiply to a negative 6. So think of what would give you the result. So you can think of negative 3 and positive 2, right? Let me write that here. Negative 3 and positive 2. That multiplies to give you a negative 6, but adds to give you a negative 1. So try changing the sign. So the sign could be changed to a positive 3 and a negative 2. It still gives you a negative 6, but the sum is a positive 1. So we want you to insert those two terms, minus 3. I switched the 2 and negative 2 and the 3 in the orders because I am supposed to factorize in the next step. So I want to keep the ones that are common, because you expect to pull out a GCF. And so you would choose the terms, arrangement of terms as suitable as possible. So this would be t minus 1 plus 3 t minus 1, because you expect this to come out to be the same. So you take that answer, you plug that in here. T minus 1 times 2t plus 3 over t minus 1. And then you can cancel out the factors. Remember not to single out the t and cancel off with a t and all that. You can never do that because of the minus sign. The entire factor has to be canceled. Okay. Needed more room. And so you now have 2t plus 3 as your end result. So don't worry if it is an expression, because we did not have a t value. So your average rate of change is 2t plus 3. Once we know what t is, for instance, now it's from 1 to t, right? If you fix your t to be 2, then you plug in 2 here. If you fix your t to be 5, then you plug in 5 here to find the answer. And that is helpful because you don't have to be fixed on a t. You got a general version to find the average rate of change. And we have a similar problem. Again, you can pause the video and see if you can recognize the answer for this. 4 to t. So this will be my a to a plus h. So f of a is f of 4, which is square root of 4. That gives me a 2. F of a plus h is f of t, which is square root of t. I have to leave it as a t. And now we have to find h. H is the difference, so t minus 4. Average rate of change will be f of a plus h, which is square root of t, minus f of a, which is 2, over t minus 4. Yeah. Now again, you have a radical on the top, so you cannot really factorize them and have them canceled off. However, if you did break down the t in the denominator, you could do that, right? So use the difference of squares, and you can break the t as root t times root t, right? So that'll be square root of t plus 2 times square root of t minus 2. This is using difference of squares. And remember that you have to cancel out the entire factor up and down. So that cancels those two off. 1 over square root of t plus 2. Technically, you can leave it like this, but if in your homework they provide additional instruction that asks you to rationalize it, or sometimes they don't say explicitly to rationalize it. We usually have to rationalize, in which case this has to be multiplied up and down by square root of t minus 2, square root of t minus 2, which will take you back to this answer. So that is the reason why I said you could leave the answer either like this, if they want it in the rationalized form, or we could write our answer like this in the reduced form, which will leave us with a radical in the denominator. I hope this section was helpful to you. This again, remember, is a part of 3.1. I will follow up with other parts in the following lectures. Thank you, class.